Welcome to today's edition of Interest, the remote engagement sessions and technologies provided to you by the ETIC at the College of Engineering and Computing Sciences at New York Tech. I am Dr. Nizik, and I will be running these sessions for you throughout. And today's session is on Introduction to Python Programming. Python is a programming language that is incredibly popular. You'll see throughout the presentation. And there's quite a bit of career opportunity for you if you do kind of engage in Python. So these interest sessions are geared to provide you with an introduction, but a working knowledge to some degree of these different technologies, but not specifically technologies that we've chosen to include in core curriculum. As an example of Java as our core programming language. These are things that are proprietary technologies that have different uses out there in the field. And if you do gain experience with these things, there are quite a number of jobs available in these specific technologies. So the interest program is geared for me as the Entrepreneurship and Technology Innovation Center to help you as students and as entrepreneurs in some cases to learn these technologies and where they fit and where they play for you as far as a career perspective. So what we're going to do is we're going to break today's session into two pieces. One is we're going to do a quick seminar on kind of some background of some programming and also specifically more so of Python, of course. Then I'm going to kind of show a short video of some projects that we work on at the ETIC using Python. And then we're going to actually break into a real demo of Python on a real working project so you can see it all kind of put together. All right, these are short sessions, 45-minute sessions. I also try to leave a little bit of time for Q&A at the end. So we're going to kind of move pretty quickly through this. And hopefully you'll get a pretty good exposure to Python and also the applications of real world applications that I'll show you kind of in action. So we will get going. So for those of you who don't know, the ETIC is our business incubator combined with a prototyping center and a student engagement center. So if you are a student with a business or you want to start a business or you have an invention, the ETIC is kind of where you come to think that through, work with us to build your initial prototypes and things like that, and also to join a whole bunch of things like Interest and Ursula and all kinds of programs we have going on that will allow you to improve and increase your skill sets. So if you want to see what we're doing and what we have going on for you, you can visit us at nyit.edu/ETIC. Take a look at some of the things we have for you as students, plus also some of the more recent activities and publications and things like that we've done. So into our specific topic today, Python and Python programming. Let's talk about Python as a career for a second. Now, there's a bunch of different programming languages. These languages are geared for you to create structured code and organized code in very proprietary syntax. So you have all kinds of different languages, some that we'll go over in a second, different options for you. But Python is one of those languages. Python became incredibly popular because it was more of a business language than a high-level technology-based language. So lots of people learned to use it to solve business problems. That being the case, there's an incredibly high demand for Python developers by business. So if you have a number of, if you have skill sets and practical skill sets and knowledge in Python, you have a number of different opportunities open to you to move into industry as a Python developer. You can see here a quick Indeed search of Python developer brings up about 18,000, 19,000 jobs available at any given time. And the salary is incredibly lucrative for a senior Python developer. So senior in this industry is not 25 years, it's 3 to 5 years of core development. So if you can build some of that, a year of that development in school already, and you can get an entry-level job, working a year or two as a junior programmer, which is still a great salary, by the way. You can qualify for these senior Python developers where you're building full applications with other team members and things like that in an agile environment. Okay, so just it's real, it's out there, it's not so far fetched as far as you getting these jobs, and it's just a few years away if you really dedicate yourself, really put in the time and effort to build real projects with, in this case, with Python. All right, so let's take a look at programming languages. We throw a lot of terms around in this interest session. We cover a lot of different applications, right? And these are proprietary applications, some of Microsoft products, and but we do cover Java, we do cover Python and things like that. Let's just break it down for a second, right? So you have IDEs or integrated development environments, and those are things like NetBeans, Microsoft Visual Studio, right? All these different IDEs or these development areas to work with other programs, but they're not the languages, right? The IDEs allow us to work in a visual environment and group our code in classes and projects and packages and methods and things like that. But it's a place to work, right? It's a tool to help us organize. The language is actually the syntax you use to tell a computer what you wanted to do with the binary data, right? What you wanted to do to organize this data and run code in a specific fashion, okay? The language is a very specific syntax based on what language you use. So if we look at the most popular languages, we have JavaScript, Python, number 2, and I'll explain why: Java, C, C++, PHP, Swift, C#, Ruby, Objective-C, and SQL. SQL is really a structured query language. It's a database language. It's not really a programming language per se. It's a store of procedures that allow that, but it did make the list as far as most popular things to be aware of and to know. If you look at Python number 2, the reason it's so popular is not so much because on the techie side, as computer scientists, we choose Python. On the business side, it's extremely easy to use and extremely flexible and extremely powerful. It has a lot of different packages that can be imported into a simple class. And those imports allow us to do things like data analytics and machine learning and object recognition and all kinds of crazy stuff that we'd have to code from scratch in other applications. So Python built in popularity in an incredibly quick, kind of way. It's been around for a long time, but its ability to do data analytics and statistics and machine learning and things like that are extremely flexible. So when you look at the C family of languages, you look at something like Java and you look at C and C++ and C#. Those are all C family languages. Those are a different syntax than Python. Python is more, if none of you will probably remember, Basic and Visual Basic has this very similar type lexicon to that Python uses in the way they structure things, right? So it's very different. The reason I bring this up is when you're learning these languages, if you wanted to learn C, C++, C#, and Java, they're pretty similar, but syntax-wise, once you learn one, they're not terribly difficult to learn the other. Python is a bit unique. It's easier, but again, the syntax is really unique where you're going to need to learn almost from scratch the Python language. Okay, so that frames Python into the overall big picture of IDEs and of languages. And as far as tier applications, when we build in C# and we build in JavaScript and Perl and PHP and things like that, we're building on this 3-tier application where it's really all web-based. Python, we're really building in like a 2-tier, like a client-server application, basically running the Python code on one machine, and we're making calls out to other machines almost in a client-server fashion. Python can run on a server that actually hosts a database. So in some sorts, it is 3-tier, but overall, when we talk about web-based development, we're really building things in other languages for that. In Python, it's really a unique language to do some really cool and really powerful things attaching to different peripherals. Like we attach to Raspberry Pis, we attach to other types of devices with Python that allow us to control them pretty easily. So what are the things we want to do and want to learn in programming theory, right? And even in not just in college, but just anytime we want to learn a language, right? We want to talk about creating classes and methods, assigning variables, performing loops, applying conditionals, if-then statements, right? Performing mathematical calculations, outputting and displaying data, abstracting, right? Complex code so that we're only looking at the raw code, display and information hiding. We don't want to have everything in one big spaghetti code type of program. We want to break it into different classes and import them in so we can get the function of those classes, but we those packages and those methods in those packages, but we don't want to make the program too complex to read and get through in our mind, right? We want to import these packages so we can get the benefits of something else like a machine learning algorithm package. We want to import that in so we can manipulate it, but we don't want to see all the coding behind it. We want to connect with peripherals. We want to control robotics and things like that, which you're going to see today. And we want to access internet resources, right? We want to be able to use a language to go out to the internet to pull stuff and learn from it, right? We want to have all these different abilities to do that. So generally, whenever we're learning any kind of language, we want to try to cover those things. The best way to do that in a session like this in a short period of time and to really have it kind of stick and make sense is to show you functional application that's in use, that's being run, that's doing a very specific test that incorporates all these things. And then we go from there. So you can say, that's what it would look like. That's how it works. And that's what it's doing. So it'll stick with you a little bit more. Okay, we're going to demonstrate Python today, and we're going to demonstrate some of the coding features and some of the syntax components so that you understand how it's different from Java like you learn in class, or how it's different from C++ that you might learn in some of the ECE programs and stuff. But we're going to do it based on an existing project that we work on at ETIC on an ongoing basis with students like yourselves. That project is called Ursula, and it's the ETIC research robot for student engagement learning activities. That's what the acronym stands for. And it's a robot designed from scratch by the ETIC for the sole purpose of engaging with students. We work with students to build new apparatus to attach to the robot, to build new code and things like that for the robot so that she can learn to do more and more things. And we do that in cooperation with students like yourselves. One of these projects was a Raspberry Pi based SenseApp project where we sense things like the accelerometer readings and the gyroscopic readings. And based on the movements of that device that we've created and the coding, the Python coding we created for that, we're able to control the robot with movements of the device, right? What this means is that we're able to consider somebody with spinal damage in a wheelchair, confined to a wheelchair that can only move their head, actually controlling through head movements up and down, left and right, controlling this robot to help them in their home, right? That's the research part of the Ursula robotics project. So what you're going to see now is kind of a demonstration of that. But what we're going to do is we're going to delve into the object itself that was created, and we're also going to delve into the Python code specifically because it's a Python interest session on how that works. All right, so let's take a look at that.
So for the Ursula program on Fridays, this is one of our latest projects. It's a Raspberry Pi with the Pi hat attached. So the Pi hat is a group of sensors that is basically a gyro, directional, and an accelerometer all combined. It's got temperature and humidity as well. And basically when we attach this to the Raspberry Pi is able to sense all that through Python code. So if we fire this up, we're going to fire it up off a battery. And you'll see the device actually fire up. And the program, the code that we wrote, is going to initiate the accelerometer, and it's going to report forward, reverse, left, and right to make sure that the program's up and running. It was put into the ETC folder to make sure that it starts up on automatic on startup. Once we see that, we'll know it's ready to go. So the program's actually loaded, and it's reporting forward, stop, left, and right is ready to be received. So as this device changes, right, using the accelerometer, changes forward momentum, reverse, or left or right, it's going to sense that. And we programmed it that when it senses it to send through the API, through the Ursula API, the proper coding. So if we turn this way, we see forward, and the robot moves forward. Forward. Okay. If we turn left, we see an L through the coding, and the robot turns left. Left. Okay, and then if we move backwards, it's just going to send a stop signal. So now we want to come up with very special ways to use this. And she's going to move forward. She's a little stuck there. Forward. We want to come up with fancy ways to use this as a wearable. So we can use it as one of our headbands. We can place it on a headband. We can place it as a wristband. Or we could simply have it as a device in our hand as a remote control. All right, so that's what we're going to be talking about this week in the Ursula weekly project.
So what you just saw was the ETIC lab, of course, and that was the Ursula robotics project that we've built from scratch, again, in cooperation and collaboration with students like yourselves. But that was one of our projects. One of the projects is this device I'm going to show you today, and you're going to kind of see it in action, and we're going to show you the code to that and how it actually interacts with that. So we had to write code to basically capture the information from the sensors. We then had to write code to evaluate that, and then we had to write code to basically make decisions off of that to say, all right, do we want it to move forward? Is the gyroscope, is the accelerometer, in other words, telling us to move forward? Is it telling us to move right? How do we know, and how do we actually tell the robot to move right? So in doing this exercise for today, we're going to demonstrate every single thing that you'd want to know about in programming theory for a particular language that we just went over, but you're going to see it in a real applicable and applied science model versus a theoretical model. Okay. All right. So let's get going on the demo. Okay. So the first thing I'll try to show you without causing too much damage here is the actual device. So just so you know that a Raspberry Pi is an actual electronic device. It's a full working computer, pretty powerful actually, held in the palm of your hand. It's about $40 or $50, so it's incredible. And then on top of that, we have this thing called a hat, hardware on top. And then this particular hat is a Sense hat, which connects to the Raspberry Pi, which is below. And that Sense hat has all the different sensors that are built into it. What we're able to do is use the Raspberry Pi with a Linux operating system built into it that we've installed on it, and then use Python that runs on that Linux operating system, right? And in Python now, what we can do is we can start reading all the different pins. They're called GPIO pins, and we can read the data from those pins, right? So what you're looking at right now is the screen of the Raspberry Pi Linux operating system, right? This is a distribution of Linux that's built specifically for Raspberry Pi. But it's no different than something like Ubuntu or Kali or CentOS. It's a version, a flavor, a distribution, as they call it, of Linux, and it happens to be specifically for Raspberry Pi. If we go to the console mode of Raspberry Pi, of the actual Pi itself, what you'll see is a command line component here, and usually what we have in any operating systems, we have some sort of a command line kind of an operation that we can work with. In this case, we have a number of different files there, but we're really only interested in one thing, and that's Pi files, right? Anything that ends in .py is an actual Python program. So similar to the way we would work with Java, where we would have classes and we would name those classes, and those classes would ultimately wind up being projects in a project folder. If we went to the actual console mode of our Windows desktop and we were running NetBeans or Eclipse or something like that, and we looked at that folder, we'd still see the same thing. We'd see separate Java, .java files. So Python works the same way. Instead of .java files, we have .py files. So each Pi file does a specific routine, but each Pi file can import in every other Pi file. So in the concept of inheritance, if you had 5 Pi files, 5 .py files, individual files on your hard drive, or in the memory as in this computer has on its flash drive, each one of those files can be imported using an import statement so that you build on inheritance, right? The concept of inheritance. So again, theory number one with building packages and classes and, or topic number one, building packages, classes, methods in Python, no real difference. We're just building individual files, .py files, which are importing in the other files when they need them, okay, through an import command. All right. What we do is we use the sudo as the administrative feature to edit code in Linux, and nano is the default editor that we use. And we're going to bring up this ercontroller.py program in edit mode. Okay. And what we're going to do is we're going to what you saw in the video was this program running. And this program booting up and basically saying, okay, I'm ready to go. And what am I reading? I'm reading from these sensors and then making decisions off of those sensors. Okay, that's what you saw in the video. Now we're going to look at what's actually happening. You saw the device. There's a physical device here that has an actual gyroscope in it and an accelerometer in it, and it has all these devices in it. We now have to look at how we actually read these. Okay, and we're going to do that with Python. It'll be a great exposure for you to Python. But on the same note, it'll cover all the different pieces that you might know in another language like Java or C++. And you say, that's how you do it in Python. Okay, so whenever we bring in packages in any languages, we want to access the methods that are incorporated in those packages so we don't have to bring them in and have them loaded in our own program, right? If we're building a program that we just want to display some simple data, but we have to import 1,000 lines of code from 3 different packages to do that, it's a mess. We'd never find out the one little line we want to do. We call it information hiding or abstraction. And we basically want to kind of just import in, right? In this case, we're importing in SenseHat, which is the package that SenseHat, the company who makes SenseHat, has a software package that we downloaded, and we basically are referencing that, right? These references, actually, we import in these packages, and they become references where we just have to, right? Once we bring them into our current Pi program or class, we can actually just access the different methods that are in SenseHat, okay? In that case. OS is the operating system package that we import into Python. So we have all the operating system controls that we want to do. Time, again, we can do delays and all that by bringing in time. And the URL lib, which allows us to import in the package for internet access. So within Python, I can now go out through this request component and request things off the internet, right? I can post things with data I have. I could call web pages and post data. I can access web pages and pull data down and process that data. This is how things like web scraping is done. I can go out to a website and pull down all the public data that they keep out there that they want people to access, the home page, the default page, or things like that. And then if I pull that data down, I can then parse through it. This is how data mining is done. This is how data analysis is done. This is how scraping is done. This is right. This is what we, this is what we use to collect data from the internet and build different, theoretical models and such. Okay. Once we set something called sense to the sense hat, which is part of that sense hat package because we've imported it in already, sense becomes an object, right? We want to instantiate object, which is part of our list of things to do in programming languages, right? Once we instantiate objects, that object sits out there in the ether, right? In the computer's memory, I call it the ether, but it's really the computer's, temporary memory, the random access memory. And once that object is out there, as long as the program is still running and that object hasn't been kind of eliminated, we can interact with that object all the time. So it's a great way to load that object and then do other things in the program while that object is sitting out there and we can interact with it. Sense in this case is now an object that we can actually, with object-oriented program, we create these objects. Sense is now an object that we can actually interact with. No matter what else we're doing, we can always call that object because it's like putting it on a shelf and then doing something else, right? It's always there, but you can do something else at the same time. All right, so that's another piece we wanted to cover in our topics for programming, right? Defining, instantiating objects, right? We want to create methods. The reason we create methods in programming is we don't want to have to redo anything, right? One of the tenets of quality software, as we call it in software engineering, is reusable code, right? We don't want to do something and recreate it every time we need to run it. That leaves challenges like once you have an error in the code, you have to fix it in 24 different places, which doesn't make it very efficient. So by creating a method that runs the same code anytime we call it, you can call that method by calling it with data. You can send data into the method so the method runs it with that data. You can pull data back out of it. And these are the way we do these methods and functions in Python, right? We use the def command, then we call it something, and then we have the open and close paren. Now, based on what we would be doing, right now we're not requiring any data in or out, so we're not telling it. But if we did, we have to define what type of data, integer, text, things like that, okay? So right now, inside these parameters, we're just kind of running some sort of code inside of it, okay? So we have methods called sense messaging forward, sense messaging stop, sense messaging left. Now, if you can guess by looking at this, what each of these methods is doing is it's calling something called sense, which is our object, right, that we've instantiated. It's calling something called show underscore message, which is not ours. Show message is a method in another package. It's in the sense hat package, okay? Once we import in that package, show message is a method just like sense messaging forward, which is ours, but it's a method in that package. Now I can call that and run it, but I don't need to know what it does. I don't need to know what it's doing to do it. I just know that when I call it, I'm going to display an F on that scrolling, that scrolling window, that display window that's on the Raspberry Pi. You saw that F and R showing up. Okay, I don't want to know how it does it. I just want to be able to do it. So it's information hiding, it's abstraction. I've abstracted, right, the show message function from that larger package that I've imported, but I don't care what the rest of it does. It's just going to confuse me when I'm trying to make my own code, right? Second thing we do is we open, right? We call a web page. In this case, it's the bot command ASPX. This is our API for the Ursula program, which we did write in C#. And we're passing in values to that ASPX page. And that ASPX page is going to populate them and insert them into the database. The robot then looks at the database and then processes those. This open command, again, it's actually going out to the internet and doing this and calling that web page. But how's it doing it? I don't care. I'm not being callous, but I do care. I'm interested in how it does it. But my point is that with information hiding and abstraction, you don't care. You want to import in the URL request library, the package. You want to import that in. Then you want to use its functions and its benefits, but you don't want to get caught up in all the code it's doing. You want to get caught up in your own code. If you had to look at all the code that SenseHat was doing and all the code that URL Live was doing and your own code, your mind would just sizzle and fry. So you want to use this concept of this abstraction to do that. Okay. So we have these different methods that we've created, and each one is displaying the proper number. It's also inserting the proper command to go in reverse, to go in forward, to go make a left, make a right. So it's populating those. Okay. We have another function or method in this case called sense excel, and in here, right, we're looking at our first loop. right? We talked about loops. One more thing that we want to be able to do with coding languages and syntax is to deal with loops, right? Loops can be for next loops or while loops, meaning that for the next amount of times for this parameter, do this, and then go to the next one, or just while something is a Boolean operator, meaning true, false, and or whatever, while something is the case, just run it indefinitely, no matter how many items there are. For next can be like as once it equals 10, then stop or whatever. But while is just, hey, while this is currently going on, just run. Don't do any checks and balances. Just run until we tell you to stop. So you see a lot of while loops in Python. Okay, in here, right? While this is true, the Boolean operator true, basically it's going to run. It sets an object called acceleration, another object name. We're using the sense object to get that. So this new object is now being set based on things that we can pull out of it. We can pull X, Y, and Z because it's programmed and it's packaged for the accelerometer to know that X, Y, and Z, sideways and so forth, are things that we want to know the acceleration rate. Once it senses acceleration, it measures that in a numeric fashion. So we're setting variables, right? One of the probably fifth or sixth items you wanted to talk about was the set of variable. This variable X, Y, and Z. Now, notice the difference in Python. If you're familiar with Java, we have to define in Java what type it is, right? We have to define the string X equals string Y, string whatever it might be, with to convert the values to a string and so forth. Python's a little more easier and forgiving, and it just kind of knows what you want to do for the most part. So it just kind of handles that on the fly. So what we have is we have three variables. A variable X, Y, and Z is set to the acceleration object, but the value of X, the numeric value of X that it's pulling out. So X is going to be a numeric value, Y is going to be a numeric value, Z is going to be a numeric value, but they're not going to be the same. They're always going to be changing because as the object is moving, it's changing those values as we do it. And then finally, we call the operating system just to do a clear, because we want to basically do some functions to just clear the screen and clear the memory and things like that. So we're just calling that. But again, the OS is an object that we're calling from the operating system piece, right? So now we have, right, our next object that we always wanted to talk about with our programming language overview or functionality are conditionals, right? With conditionals, we want to basically say if this equals that, or is greater than this, or less than that, or if this and that, or that happens, then do this, right? We want to be able to do conditionals with Boolean operators that basically say, if these conditions exist, do this. If these conditions exist, do that, right? We want to use those pieces. So if you see here, right, we should be very familiar to the if-then statement, but notice there's no then. In Python, it's just if and else if. There's no then. It just basically is saying if, in this case, y is greater than 0.3, and in this case, we're going to run this method called sends messaging left. So basically what we did was, as we were kind of using the accelerometer at first, we would just wrote a short program to display what the accelerometer was showing. And we got used to the numbers. And we're like, when we go left, it's always this. When we go right, it's never greater than this. When we go forward, it's never greater than this. So we started to figure out how far right we'd have to go to get a measurement, how far left we have to go. And then we figured out that yeah, if I had something on my head and I was turning my head left and right, you don't want to go all the way this way. You want to basically just be able to control it like this. And that was kind of our limit. All right. So we found out those numerical limits and then included them into the program so that we could code that. The next component, right, for programming languages that we wanted to make sure we displayed and covered is just displaying and outputting data, right? So in this case, we're just using a basic print function in Python that will just print on the screen whatever we have. And in this case, we're putting out these particular variables. We're using quotes to kind of show that these things are going to show, the brackets are going to show the value of that item. The quotes are going to have the text in there as well. And then we're formatting them on how we want them to show up, all right? Now, time was an object we created, and sleep is one of the functions of that object, or one of the methods of that object. So in this case, the time.sleep is in seconds, and we basically want to pause. It's like the equivalent of a Java, I believe it's pause, but Java does it in milliseconds, I think. So I'm confusing the languages right now, but basically it's the equivalent of pause, where we can stop processing for a period of time. Whatever process is happening, it stops, and then it runs a new process that basically counts how many seconds you want to pause for, and then goes back to the other process, right? So you're not really pausing when you're not doing anything. You're just stopping one process to do another process, which is simply a counter. But in this case, the sleep object allows us to do that, Okay. So then we have another function called sense gyro, and we wanted to be able to control this through one or two ways. One was the accelerometer and how you're moving left and right as far as the actual movement. And the accelerometer turned out to be so sensitive that even the slightest move forward was measurable. So we said, okay, let's take a look at that. When we did the gyro wasn't as reliable. It had to be configured and calibrated every time. And then as you were moving, it really didn't get the same values every time, right? So we looked at the two of them and said, the accelerometer is just so much more accurate and dependable. And this is where the research piece comes in. Who knew, right? When something like this, we chose to use the accelerometer because the data that came from the gyro was just unreliable as far as what we wanted to do. And when you're dealing with, a 150-pound robot with high torque motors on it, you don't want it running over somebody, right? So, or causing damage. So we didn't want to be able to have something unpredictable. So we chose, right, as developers, the accelerometer over the gyro. Okay, so this is the coding similar to the accelerometer, where we're collecting the pitch, like an aircraft, autopilot, the pitch, yaw, and the roll, right? But those numbers, again, are so drastically different based on how it's behaving that we chose the other component. Okay. Then we always have, in a programming language, we have something called the main method, right? In Java, we have the main method. Really, anyway, the program needs to know what method to start with, right? So here, as long as we have this, there's two things. One is the main method, and the second is this component down here that basically has this if name equals main, right? Python looks at this particular method first, and it looks to say, if we have one called main, start with that main, run the main method, right? So basically, this is the way that Python knows where to start your particular project, right? If you're importing in a bunch of other Py programs, you wouldn't have a main method in there, and you certainly wouldn't have the startup parameter there. You'd want to run one program with that. If you have two mains, it'll crash, and if you have two different startup procedures, it'll crash. So basically, you'll have Py programs, .py programs, .py extension programs that will have all kinds of different methods and processes in them, but you'll just be importing them so that you can reference them. Okay, you only have one program in your project that will have the startup routine. So what we're telling the program to do, and the main method is to print running first of all, so we know it's running and started. We want it to print F. We want it to basically show on the screen that F is lighting up, right? We want to kind of have a start routine to show us almost like a utility check, like a systems check that kind of tells us everything is on. And once that is all displayed and we know it's running, then we run the sense accelerometer, sense accel method. And if we go back to the sense accel method, what you'll see is that basically, right, we're not going to stop it. We're basically just doing while true. We don't ever stop it. We could, we just didn't. We just wanted it to run forever until we hit, there's a Control-C command where you can hit the stop the program. But basically, we just wanted this thing to run all the time until, really until we forcefully stopped it. But basically, what you see here is it's just going to continually loop through this piece. It's going to capture the sense hat accelerometer settings for X, Y, and Z. It's going to measure them based on what it's seeing. And if it doesn't see the value that it's looking for, greater than or less than, it doesn't do anything. It just goes back and captures it again. But when it captures it a second time, now it's going to say, oh, this is greater than this. Then it's going to actually send and insert data into the internet-based database we have, which controls the robot, which I will show you during the seminar too. Let's just show you, we'll get out of this program, and we will kind of show you whenever we want to run a Python program. We call Python 3. So one of the idiosyncrasies with Python is that it's not truly compilable, like you create a jar file for a Java program or an exe. Python has some utilities to do things like that, but essentially you're always running the Python program and the coding, which makes it more of a single user type program to do very, very complex tasks. But again, from a distributed point of view, for like millions of people to use it, the one program you created, it's not exactly great for that. But in this case, what we'll do is we'll do controller.py, and once we run this, it's going to run the Python 3 compiler basically, and it's going to open the controller code, and it's going to start running what you see, what we programmed it to do. And what you'll see is that that it's doing what we kind of set it to do, right? So now it's kind of, right? Now, as I hold this straight and flat, okay, you're going to see those numbers, and those numbers are changing based on what I'm giving it, right? But if I turn it really hard to the left, now those numbers increase. If I turn it really hard to the right, okay, now one of those numbers increase, okay? If I go forward, one of those numbers increases, right? If I go backwards, one of those numbers decreases. So depending on which direction I'm turning the, right, I'm turning the actual device, the numeric values of those sensors, as far as what, excuse me, as far as what data it's capturing, is increasing or decreasing. We're looking at that in our while loop and we're measuring that. And based on the value, right, on whatever parameter we set it to, it's then inserting data into our web database. Now, what does that mean? Well, what it means, I just did Control-C to stop the program. What that means is if I went to the Ursula website, and by the way, this is also created by us at the ETIC. So this web portal is for the end user to create their Ursula programs and codes and do their research on. So if I were to log into the Ursula website and I go to developers and I go to the code testing center, if you look here, these entry IDs today at 10:43 at 41 seconds, 44 seconds, 41, 36 seconds, these are the database entries, which are a cloud-based system. We have an image in the cloud that, you know, is nyitetic.nyit.edu. That's our domain name. We're taking a local Python program that's running on my laptop. It actually is running on a Raspberry Pi, but since the Raspberry Pi is infinite access, so we've imported in the URL lib package. We're able to connect to the internet to a specific website and actually insert data into that website, right? So this is a demonstration of two complete different platforms and systems, could be halfway across the world, you know, and they're still communicating, right? This gives us the ability, by working in this fashion, this gives us the ability to work with any student anywhere in the world. We could have students that go home for break and they might be in different countries and things like that. They can still work on their projects in the lab on Ursula. That's why we do it this way, so that we can engage with students in high school classrooms, we can engage with students at home, we can engage with students at different campuses. This gives us the ability to do that. This is a good example of how the ercontroller.py, because we import in the URL lib request file, because we import that in, we have all these abilities to actually communicate with web servers and websites. Now I'm choosing to call a web page and send data to it. That's what I'm choosing to do in this program. But you can call a web page and pull data back down. You can pull that data back down and parse it and say, okay, what was the domain name? What was the IP address? What was the product name? What was the price of the product, right? We have all kinds of neat stories of students that I've heard of that have programs that go out and get from 6 and 10 and 12 different websites the price of some sort of a new item that came out for comparative purposes, right? So there's all kinds of new things that you can do with Python that are very easy because they've got these packages built in. Let's go back to our kind of concepts here as far as what we wanted to talk about with a programming language. In one demonstration, we've shown you how powerful Python is and can be. We've shown you that there is a career path and thousands of jobs open that are really great paying jobs for Python developers. And we've also shown you that there's real applicable ways to apply Python at New York Tech now through the ETIC and through our Ursula program. But, you know, keep in mind, these things are free. Everything that we talk about in interest programs, SQL Server, Microsoft Visual Studio, C#, everything, Python, they're all free. You can go and download Python now and create packages and programs that do things and keep learning on it while you're in school, all right? If you want to apply those things to real working products, come to the ETIC and we'll connect you with whatever we're doing. And you can apply those so you can build sort of a technology portfolio to display, to show and demonstrate to potential employers. But essentially, this particular concept for Python allows us to know what the language does, know that there's a career path for Python, know that there's a way to apply it and do some amazing things with it, and also know that it's available for you, you know, in a number of different ways in your tech, but also once you graduate and start looking for a job, you should be considering seriously, if you have Python experience, look for jobs in Python, because there's a ton of jobs out there for people, business developers that want students to focus specifically on data analytics, data mining, data warehousing, things like that, machine learning, all kinds of stuff for Python. So with that being said, I'm going to end the session recording for right now, and I'm going to say thank you, and I hope you enjoyed it. And I'm going to open up for a few questions now, and I'll see you at the next intro session.